Hi dear students, in the previous videos I explained the concept of center of mass and the calculation of center of mass for discrete particle systems, continuous mass distribution objects. In this video, I am going to explain how to find the planar type objects and the center of mass of objects from which certain mass is removed. Center of mass of planar objects. Center of mass of planar objects. For planar objects, that is 2D objects, having uniform thickness, the position of center of mass can be calculated by using the following formula. By using the following formula, that is RC bar is equal to M1 R1 bar plus M2 R2 bar plus and so on Mn Rn bar by M1 plus M2 plus and so on plus Mn plus Mn. This is equal to mass. Mass is equal to volume into density. Mass is equal to volume into density. Okay. So since the object is made up of same material, density is same. So mass is equal to volume into density. Volume means area into thickness into density. So density rho, area A1, thickness T. Thickness of whole object is same, density of whole object is same, R1 bar plus rho A2 T R2 bar plus and so on divided by M1 rho A1 T plus rho A2 T plus and so on. Here rho T gets cancelled because it is common in both numerator and denominator. So rho T takes common. A1 R1 bar plus A2 R2 bar divided by rho T into A1 plus A2. Rho T gets cancelled. Therefore, the center of mass of a planar type body, laminar type body, plane type body, okay, is given by A1 R1 bar plus A2 R2 bar by A1 plus A2 plus and so on. This is the formula for laminar type objects or planar type objects, that is 2D objects. That means the object is distributed, the object is occupies certain area on this board, then that is called 2D body or planar type object. The formula is A1 R1 bar plus A2 R2 bar and so on divided by A1 plus A2. Okay. Now let us see, let us do some an example on this concept. Example problem. Okay. Let us see one example. This is the origin of coordinate system 0, 0. Origin of coordinate system 0, 0. This is the given laminar type object or given object. Laminar type object or planar object. Planar object. Okay. The dimensions are this is 2 meter. This is 1 meter. This is also 1 meter. And this is 1 meter. And this is also 1 meter. These are the dimensions of the given planar object, given laminar type object. How do you find out this center of mass? Center of mass. Okay, so this is assumed as a L-shaped sheet, L-shaped sheet, L-shaped sheet, and its dimensions are given. In doing such type of problems, first of all, let us divide the given laminar sheet, given planar sheet into different parts. The parts must be regular geometrical figure, regular geometrical figure. Okay, so we can divide this given planar type sheet. The given laminar type sheet is divided into two parts. One part is a square, another part is a rectangle, which are regular shaped, regular shaped bodies, regular shaped bodies. Okay, triangle, rectangle, and triangle. Regular shaped bodies. Okay, this is a square sheet and this is a rectangular sheet. In the last video, I said that for regular shaped, regular uniform, for uniform regular shaped objects, for uniform regular shaped objects like rectangle, square, or triangle, their center of mass lies at its geometric center. Lies at its geometric center. So first of all, locate. Okay, after dividing the given planar sheet into regular shaped objects, then next step is locate their individual center of mass. Where is the center of mass of this square sheet? At its geometric center. At its geometric center. So this is its geometric center. So its center of mass C1 is there. And for rectangle, the center of mass located at its geometric center. So its geometric center is at C2. So C1 and C2 are the center of mass of sphere and rectangle. That means we can say that the whole mass of this square is concentrated at C1 and the whole mass of rectangle is concentrated at C2. Okay, Nana? C2. Therefore, the coordinates of C1 are okay, coordinates of C1 with respect to this origin. Okay, C1 x coordinate. This distance is 1 meter now. So C1 is at the distance of meter from y-axis now. From y-axis, what is the distance of C1? Perpendicular distance of C1 from y-axis, half meter. This is 1, therefore this is half. So exactly half is the x coordinate of C1 and y coordinate. Y coordinate means perpendicular distance of C1 from x-axis, that is from this point to this point. This length is 1 meter and this length is also 1 meter, but C1 is a distance half meter from this side of the square. Okay, therefore this is half plus this is 1. 1 plus half, 1 and half. 1 and half means 3 by 2. The 1 by 2 comma 3 by 2 are the coordinates of C1 and coordinates of C2. Coordinates of C2. C2 is at a perpendicular distance. At a perpendicular distance, this distance is nothing but x2 x coordinate of C2, that is x2. This distance is half of this total length, half of this total length. This total length is 1 plus 1, 2 meter. Therefore, the x coordinate of C2 is 1 meter. So 1 comma and y coordinate means perpendicular distance of C2 from x-axis. So this length is y coordinate of C2. This length is exactly half of this total length, total side 1 meter, that is half. Okay. Okay, Nana? Okay. Next. This is C1. These are C1 coordinates, these are C2 coordinates. That means x1 is half, y1 is 3 by 2. x2 is 1, y2 is half. Therefore, next, mass is proportional to area since thickness is uniform, density is same. So M1 is proportional to area. Use this formula. Use this formula first. RC bar is equal to A1. A1 means area of the first figure. Okay, that is this is 1. This is 1 into 1 into R1 bar. R1 bar means position vector of C1. Position vector of C1 is half I cap plus 3 by 2 j cap. Half I cap. Half is x coordinate. X coordinate means it is along x-axis, that is equal to denoted by I cap. Y coordinate means that is along y-axis, that is denoted by j cap. Plus A2. A2 is area of rectangular sheet. This is 2. This is 1. 2 into 1, 2 into R2 bar. Its coordinates are 1 comma half. Therefore, 1 into I cap plus half j cap divided by A1 plus A2. A1 plus A2 is 1 plus 2, 3. This is equal to Nana. Half I cap plus 2 I cap. 2 I cap here half I cap. 2 plus 1 by 2. 2 plus 1 by 2 means 5 by 2. 2 and half na, that is 5 by 2 I cap plus 3 by 2 j cap plus 1 by 2 j cap. 3 by 2 plus 1 by 2. 2. 3 by 2, 1.5, 1 by 2, 0.5. 1.5 plus 0.5, 2 j cap. Divided by 3. This is equal to 5 by 6 I cap plus 2 by 3 j cap. That is the position vector of the center of mass. Position vector of the center of mass with respect to this origin. Okay, we can say that the x coordinate of center of mass is 5 by 6, y coordinate of center of mass is 2 by 3. Now let us find x and y coordinates separately. Okay, xc is equal to a1 x1, a1 is 1 into x1 is 1 by 2 plus a2 x2, a2 means 2 into x2 means 1 by a1 plus a2 3, that is equal to 6. 2 plus half, 2 and half. 2 and half means 5 by 2. 5 by 2 by 3. That is 5 by 6. That is x coordinate of center of mass. Next, y coordinate of center of mass. Yc is equal to a1 by 1. a1 is 1 into y1 is 3 by 2 plus a2 is 2 into y3 is 1 by 2 divided by a1 plus a2 3. This is equal to 3 by 2 plus 1. This is 3 by 2 now plus 2 into half. 3 by 2 plus 1. 3 by 2. 3 by 2 plus 1. 5 by 1 into half I cap plus 2 into 1 into half I cap plus 3 by 2 j cap plus 2 into 1 I cap plus half j cap. Okay, this is half plus 2. 2 and half means 5 by 2 I cap. 3 by 2 plus 1 sorry, 3 by 2 plus 3 by 2 plus 1. 3 by 2 plus 3 by 2 plus 1, 5 by 2. 5 by 2. That means 5 by 6. Here also it is 1 plus 3 by 2, 5 by 2 by 3. So the coordinates of center of mass are 5 by 6 comma 5 by 6. This is the way to calculate the center of mass of planar type bodies or random type objects. Okay. What is the first step? Once again, listen. What is the first step? Divide the given laminar type objects and planar type objects into different regular shaped objects. Here, by drawing the dotted line here, we got two shapes. Okay, one is square and another one is rectangle. For regular shaped objects, their center of mass lies at its geometrical center, as I said earlier. Therefore, locate their center of masses at their geometric centers. Those are C1 and C2. Next, write the coordinates of C1 and C2. After writing, find xc and yc by using m1 x1 plus m2 x2 by m1 plus m2. But here m is proportional to area. Therefore, a1 x1 plus a2 x2 by a1 plus a2, yc is equal to a1 y1 plus a2 y2 by a1 plus a2. Okay. Next important concept is center of mass of rigid body from which some mass is removed. Some portion is removed. Some portion is removed. Okay, here mass is removed. Mass is removed means in the formulas minus comes everywhere. So R3 bar is equal to M1 R1 bar minus M2 R2 bar by M1 minus M2. And since mass is proportional to area, then it is A1 R1 bar minus A2 R2 bar divided by A1 minus B. And for coordinates, for calculating x coordinate xc, this is equal to M1 x1 minus M2 x2 by M1 minus M2. That is equal to A1 x1 minus A2 x2 by A1 minus U. For yc, it is M1 y1 minus M2 y2 by M1 minus M2 and is equal to A1 y1 minus A2 y2 by A1 minus U. Similarly, for ZC, M1 Z1 minus M2 Z2 by M1 minus M2, that is equal to A1 Z1 minus A2 Z2 by A1 minus A. Here M1 R1 bar or A1 X1 Y1 Z1 are meant for the values M1 R1 bar A1 X1 Y1 Z1 are the values for whole body and M2 R2 bar X2 Y2 Z2 are the values for removed portion. Removed portion are the values for removed portion. Example problem. Okay. This is a circular sheet. Whose center lies here. This is a circular sheet whose center lies here, from which this certain portion is removed. From which this part is removed. Okay. Now, after removing this portion, where is the center of mass of the remaining part? Where is the center of mass of the remaining portion? For the whole body, COM is at O, and this O has coordinates at O whose coordinates are 0, 0. Whose coordinates are 0, 0. This is the origin of this system, the XY system. And this is the center of the remote portion. This is the center of the remote portion. Let it is C, whose coordinates are C is the COM of removed part, and that C has coordinates. Let A is the radius of the whole object. A is the radius of the whole object. Then O to C is A by 2. O to C is A by 2. This is A. This is A. C is exactly at the middle. Therefore, it is A by 2, 0. So for whole object, x1 is 0, y1 is 0. For the remote portion, x2 is A by 2, y2 is 0. Next, area A1 is equal to pi a square. A2, area of remote portion. Radius is A by 2 na? Radius is A by 2 na? Radius is A by 2. Therefore, pi into A by 2 square. I ask pi into A by 2 square. Now, apply this formula for XC. XC is equal to A1 x1, A1 pi a square into x1 0 minus A2 pi a square by 4 into x2 is A by 2 divided by A1 minus A2 pi a square minus pi a square by 4. This is equal to pi a square into 0, 0 minus pi a cube by 8 divided by pi a cube by 8 minus pi into a cube by 8 divided by 4 pi a square minus pi square 3 pi a square by 4. Pi gets cancelled, a square cancels, a cube 8 times. So this is 4 na. This is equal to minus a by 8 divided by 3 by 4 means into 4 by 3. 4 cancels 8 2 times. This is equal to minus a by 6. So x coordinate of center of mass is minus a by 6 and the y coordinate of center of mass is 0. Yc is 0 since y1 is 0, y2 is 0. Therefore, the coordinates of center of mass of the remaining portion is minus a by 6, 0. Minus a by 6, 0. So, coordinates of center of mass of the remaining portion is minus a by 6, 0. Xc minus a by 6, 0. Minus sign indicates that the center of mass is on the left side of the origin. On the left side of the origin. So, certain mass is removed from the object, then center of mass shifts in the opposite direction of the removed portion. Opposite direction of the removed portion. Here, right side portion is removed. So, center of mass shifts to left. If left side portion is removed, then center of mass will shift towards right. If this portion is removed, then center of mass shifts down. If this portion is removed, then the center of mass will shift up. So this is the concept of center of mass of removed rigid body from which some part is removed, and one example. Thank you.